Okay, so for this part of 10.4, we're going to be adding and subtracting radicals. And in the first part of 10.4, everything was the same on the inside. The second part we're going to look at is where that you have something different on the inside. And the inside number is what they call the radicand, so with different radicands. And again, inside number being the number that's inside the radical that we're looking at. Okay, and the very first thing that you want to do when you're working through these is you've got to take the inside number that you have, and you're going to have to just break it down as much as you can. So we'll call break it down, they would call it simplifying. So break down or simplify the inside number as much as possible. And then once you've done that, you should have one, because most of these will probably give you 3 terms when you're going through these, and at least 2 of the terms you're probably going to be able to add or subtract. Sometimes it may be all 3. So once you've done that, where you've broken everything down as much as you can, then just do like we're doing in the first part of 10.4, where you add or subtract the terms with common or like radicands. Okay, so here's first a few examples that we'll look at. So let's give you square root of 45 plus 2 square root of 20 plus square root of 810. Okay, so first thing you want to do is take all the different parts that you have and just break them down as much as you can. Square root of 45, if you start to break it down, you can make that 9 times 5. Okay, and hopefully for that one, as soon as you see the square root of 9, 9 is the perfect square root. So you could take the square root of 9 and make it just 3. And 5 is a prime number, so you can't break it down any farther, so that part would just be 3 square root of 5. Okay, 2 square root of 20. And sometimes with these, they'll give you a hint that if this one's square root of 5, you might want to look at taking a 5 out of this one. So if you do that with the 20, that's 5 times 4. So there's your square root of 5 that would make the common terms. Take the square root of 4 and make it 2. And you had the 2 that was in front. So technically you go back and put that plus 2 there. 810. You could try dividing it by 5, but hopefully on that one, square root of 81, that if you've got 810, if you think about that as being 81 times 10, again, 81 is a perfect square root, so you could rewrite that as 9 square root of 10. And if they give you a big number like 810, then there should be one that you should be able to take a perfect square root number out of it fairly easy. They shouldn't give you that where you've got to go back and break it down in all terms of 2s and 3s and 5s, because that would probably take a while. Okay, so you got 3 square root of 5. This one you've got 2 times 2, so make that 4 square root of 5. And on the back end of this one, we've got the 9 square root of 10. So the 2 you can add together would be the 2 that's got the square root of 5. So you've got 3 square root of 5 plus 4 square root of 5. So for that part, you can put it together and make it 7 square root of 5. And the 9 square root of 10 is a different radical on the inside. Nothing, you can break it down as 5 times 2, but you don't have any pairs of anything. So for that one, that would be the final answer that you're looking for. Well, let's give you another one of those. Let's do 4 square root of 63. Square root of 28. And then minus 7 square root of 7. All right, take the 63. Start going through the different numbers. Again, first thing I'm kind of thinking for that one is 9 times 7, so that you've got perfect square root with the 9, so you can make that 3 square root of 7. Again, 4 is already up front, so it's just 4 times the 3. 28, there's really only 2 ways to break that one down. If you take 28 and start breaking it down, you could either do 2 times 14, or you could also do 4 times 7. And if you go to 4 times 7, there's another perfect square root of 4. So you can make it 2 square root of 7. And 7 square root of 7 at the end, well, it's already broken down. So then we've got it there. All right, and the only other thing to do is go ahead and do the 4 times 3 and make it 12. And now they're all like terms with the square root of 7s, so then you can just go back and add the numbers that's in front. So really it's 12 plus 2 minus 7, and all that's times the square root of 7. So we've got 14 minus 7. So eventually for that one gets 7 square root of 7. Okay, and again, most of the time when you start breaking these down, you should have at least 2 of the terms. There may be a rare occasion where when you break all 3 terms down that there may all 3 be different radicals on the inside, but more than likely you should have it so that at least 2 of them you can add together. Occasionally you may get a few problems, but most of the time it's just it just makes it work a lot better if you've got 2 that you can go back and combine some like terms with it. Okay, so after you've got some with just the numbers, then they're going to throw some variables at you. So let's go 2x square root of 80, x to the third, and then minus square root of 20, not there, x to the fifth. All right, instead of doing the same thing, that you take whatever you have on the inside, break it down as much as you possibly can, and then see if you have anything that's like terms. Okay, with a square root of 80, you can do that as 16 times 5. Again, you can do 8 times 10 and break it down, but the last problem we did, we had an 80 and we can make it 16 times 5, so I'm kind of sticking with that one. With the x's, you've got x to the third, and you can look at it a couple of different ways. If it's just a small amount of x's, I would just go ahead and write those x's off at the end of it. So you can do the square root of 16, make that 4. You've got a pair of x's here, so you can put that x on the outside. And when you do that, you're left with the 5 and the x on the inside. And the big thing for this one is, don't forget that in front you had the 2x that was already here. So basically you're still going to have that 2x in front. So it's 2x times 4x times the square root of 5x. Okay, and then just to finish this one off, when you do 2x times 4x, that would be an 8x squared. And then the square root of 5x would just hang out behind it. All right, then we'll do the same thing with the 20x to the 5th. We'll break it down as much as we can. And again, if you break this one down at the square root of 5, then there's probably a hint that you're probably going to have a square root of 5 left on this one. So for the 20 that's here, that's 4 times 5. Anyway, with a small amount of x's, sometimes it's easier just to go ahead and write out 5 x's. So square root of 4, make that 2. There's one pair of x's, and there's another pair of x's. So we can take out 2 pairs of x's or just make it x squared. And again, you've got the 5 and the x left on the inside. And we still have the minus in the middle. Okay, so for this one, nothing really to do for that part. Just bring it down. So we got minus 2x squared times the square root of 5x. Okay, and then you're looking for, again, this square root is exactly the same as that one, and both square root of 5x. So now you can take the terms in front, take the 8x squared, and subtract it with the 2x squared. So really it's just 8 minus 2, because they're both x squared terms, so it's just 8 minus 2. That'll make that out to be 6. And then just x squared will follow with it, and then it's going to be the square root of 5x. All right, let's give you one more of those. Start with the square root of 98x to the 3rd minus 3x square root of 8x, then plus square root of 2x to the 3rd. Okay, so take all the numbers again, just take it one piece at a time and start breaking it down. With a square root of 98, if you notice how this one at the end's got a 2, go ahead and think about it as dividing it by 2 just to get started. So that would be 49 times 2, and then you've got x to the 3rd. So square root of 49, that's a perfect square number. We can make that 7. You've also got a pair of x's, so we can put that x on the outside. And on the inside, that's going to leave you with the square root of 2x.